Dr. Clyde is one of the founders and currently a director of the company Carne Technologies. Clyde studied animal science and physiology. Wow. Clyde is well recognized and highly regarded international for his expertise in human studying and slaughter systems. In this capacity, he works with meat companies all around the world, providing practical solutions and opportunities to the increasing demanding of criteria of animal welfare, religious requirements, safe working practices, and meat quality. Today, Clyde will give a presentation of those elements from his perspective. Clyde, please come up and give us your show.
Well, thank you, Theo. And I have to say, after that rather epic scale, the presentation from Professor Poliani, I'm going to drag you down to a very, very much smaller scale, which is one small part of our business as a small company in a very small country, other end of the world. So I hope you can live with the whiplash that you might experience in all this. But what I'd like to do, I'll just give you a little bit of background of the business and how we got there. My own background has been in research at the meat research in Bristol and also at the meat industry research in New Zealand. So very much involved in the meat science, it's sort of commercial end of meat science research as part of those organizations. But 15 years ago, we decided to start a business to commercialize some of the knowledge that we developed. We continued to have an R&D component funded through industry good bodies, as well as directly from companies. And we did some development of our own within the company. So we sort of became a little bit of a hybrid sort of organization between a purely R&D sort of research organization and a commercial one. But it was very useful from our point of view to have a foot in both camps. And as part of that, we developed our own equipment, which we now also commercialize and provide to industry, which we think or we hope is going to be an improvement over what some of the alternatives that are around. So what I'd like to do is just focus on one particular area, which is the part of our business related to try and offer services to improve product quality. Now, obviously, everybody wants better quality. Nobody's actually going to be happier with lesser quality. The key question, though, is that part of our business developed was some of the constraints within the meat industry, the structural constraints within the meat industry that makes it difficult for companies to take on strategies to improve quality because of the difficulties in getting a decent return for it. In some cases, it's easy. In other cases, it's much more difficult. And it's really sort of working through some of those sorts of difficulties that are the basis of this particular presentation, with particular emphasis on electrical stimulation. Electrical stimulation as a case study, so to speak, because electrical stimulation has been around for a long time. It's used reasonably extensively around the world, but possibly not with a very clear recognition of what it offers by way of processing opportunities and the opportunities to actually make it a better tool for optimizing quality. Now, when I say quality here, I'm really talking only about those aspects of meat quality that can be influenced by processing, post-mortem processing of the carcass. We're not looking here at live animal characteristics or production characteristics, obviously is very important in their own ways for quality, but just those things that we can influence by way of mechanisms involved in the processing of the carcasses. And this is where stimulation of you becomes very, very important. Just to give a little bit of background to what we're referring to here, we sort of view this as being a processing space. It's a very dynamic, in terms of how we use electrical stimulation. It's a very dynamic process because it isn't just electrical stimulation per se. It always has to be with reference to the chilling conditions within the carcass. So we often get asked, well, what is the what pH target should I be going for, or what chilling rates do I need? You can't separate the two out. They both have to be dealt with together. And if we look at this sort of simple sort of graphical representation, we have on the one hand the chilling rates within the carcass versus how much electrical stimulation on the vertical axis, how much electrical stimulation you choose to use. And you can actually get to the same endpoint in terms of your product by choosing some combination, but choosing a number of different combinations of the two variables. Now, chilling rate is basically, an oil tanker. You can't really do a lot with it by way of changing directions. It's a big capital investment. So it sort of is what it is, and you have to deal with hygiene regulations and boning room temperatures and all kinds of other things. So that's a very difficult component of your processing to vary to any significant degree. On the other hand, electrical stimulation is extremely flexible. You can do a lot with it. It's not particularly expensive by comparison to your chilling requirements. You can modify it relatively easily, but that's not usually how electrical stimulation is used. You sort of plug it in, give it stimulation, because it's going to do something good to the meat. So we were looking really at trying to develop ways to make that a much more precise technology, and recognize that you may need to give different levels of electrical stimulation to serve different purposes. So if we look at this graph, we've got the two corners in red, which are basically the troublesome areas in your processing conditions. On the one hand, if you chill very fast and your pH decline is very slow, so you haven't done any stimulation, you're getting into this problem of cold contractions of your muscles, which makes the meat tough and doesn't go anywhere and doesn't tenderize. At the other extreme, your pHs are too low while your temperatures are too high, and you get this denaturation, very similar to the PSC condition in pigs. And you can certainly generate that in cattle and in lamb by too much stimulation relative to how fast you're chilling. But within those two extremes, you have really quite a lot of operating space to work with, as long as you've got a stimulation system that you can target for the particular chilling characteristics you're looking for. And really, you need to also think of it not just in terms of what your chiller settings are, but really the fact that the carcass temperature is what matters, and that's also going to vary within the context of your chilling conditions. So carcass weight is the most obvious one. A big carcass is going to cool more slowly. But even within a carcass, you've got a great big fat leg versus a much smaller loin that will cool much more quickly. Of course, most meat science is based around what's happening in the loin without perhaps giving the leg muscles the due consideration. So you need to find a system that will actually accommodate those sort of differences if we're going to try and be more exact about how we're going to process our carcasses. And even within that processing space, I'll just identify quickly, you can also modify some of the opportunity, or you can influence the way that the meat progresses in the post-Riga period in terms of the tenderization, in terms of some of the other quality characteristics around color and water binding capacity. You can modify those by operating more exact within that processing space, either closer to the hot end, the denaturing end, or on the colder end, depending on what kind of product you're generating and what kind of market you're generating it for. So there's a lot of opportunities here. As long as you can be reasonably accurate about how you deliver your stimulation. Now, if we go back to the old days, you really have traditionally you have two options. You can do a low voltage stimulation during bleeding. So you're looking at very inexpensive equipment, low voltage, so it's nice and safe. But the problem is it really doesn't give you a particularly precise outcome. There's a lot of variability in terms of how the pH decline is being generated by this particular system. Or you can look at a system that was developed in New Zealand, which uses a magnificently high voltage of over 1,000 volts. So very dangerous. You need lots of safety precautions around it. And it actually gives you a very reliable result as long as you want a very low pH, because it is really kind of nuclear. It really forces the pH down at a terrific rate. And it's very difficult getting anything intermediate with that kind of stimulation system. It was developed in New Zealand for lamb, which cool quite quickly anyway, but particularly lamb that are going almost immediately into freezers. So you really need to get the pH down as fast as you can. It was developed to really extract. It's the last drop of pH decline that you possibly can get. Where that 1,143 volts came from was something that kind of intrigued me when I went to Marin's, where this was all developed. It was all done by the time I got there. But as far as I can tell, when they were developing this system or experimenting with this system, there just happened to be a very large transformer kicking around in the workshop that turned out to be the transformer they used. It worked very well, so that became the specification. Works, don't fix it, but maybe that wasn't really the most exacting procedure to find the optimum voltage. And since then, more recently, in some work that I was involved in with Australian groups, the sort of medium voltage concept of using just a much lower voltage, much safer voltage, but one which can actually get you pretty much to the same place as the very high voltage is concerned, but maybe takes a bit longer to get there in terms of the duration of stimulation, but also gives you a much better opportunity to find intermediate levels of stimulation so that you can actually target your stimulation for a particular purpose in a way that's much more difficult with the traditional ways of doing it. So this is kind of the logic that got us through all this. And just to give you an example of what I meant by the fast and the slow processing, within that processing space, if you can target your pH correctly, you can go for deliberately trying to accelerate the aging process, and you use your temperature controls on this. So at one extreme, you can produce a much faster tenderization. The endpoint is the same in both cases, but you get there faster, which can have some very important commercial opportunities, particularly if you're looking at a local market, the need where the product is going to be on the shelf pretty quickly, or if you've got a frozen product that you need to try and get to some reasonable level of tenderness before it ends up frozen, where all that proteolytic activity stops. So you can deliberately look for commercial opportunities by generating a much faster much faster rate of tenderization, or at the other extreme, for example, for New Zealand chilled export, that's going to sit on a boat for 6 or 7 weeks. The last thing you want to do is accelerate anything because you want it to be as stable as possible. So you would deliberately go for a much slower process in order to get a product that's going to have better microbiology because you've got lower temperatures, and the biochemical events in the meat have been slowed down as much as possible to give you as much stability as possible. So nothing happened. Okay. Huh? Help? Anything happening? I'm pushing the go forward button, which is what I did before. Point in the right direction. I got a keyboard. Oh yeah, okay. Now we're cooking. What am I going to push now? Okay. Paper is actually quite a good thing, isn't it? Can you make that work? Okay, thank you. So I've probably been pushing a bit randomly as I spoke. So what we're looking at then is developing some hardware that's actually going to give us a little bit more control over the simulation process. And for that, we did a lot of work with electrical pulse durations and pulse widths and frequencies and those sorts of things to try and give you the kind of control that we were looking for. So you're looking directly at the electronics, which we then also developed and commercialized. This was also really to find ways to stimulate the loin effectively, but minimize the stimulation of the leg. So within a carcass, get some differential stimulation, which is possible if with the appropriate choice of electrical parameters. Then you want to monitor the carcasses, in particular the weight, but also how they're responding to the stimulation. So we introduced load cells into the rail during the stimulation to give you that kind of feedback. And then you've got a sort of a software control system that looks after the whole thing and makes the decisions as to what kind of stimulation, how long the stimulation should last for the different carcasses as they go along. So that's what we sort of offer. And then as part of the commercialization and the validation for the particular companies that take this sort of thing on, then we've also went to the trouble of sort of developing a simple methodologies for measuring tenderness, because that's really a key part of what this whole process is. So you've a simple tenderometer, as we call it, measures shear force, same sort of thing that happens in the laboratory and very comparable in terms of the results to laboratory systems, but one that is much, much less pricey and easier to operate, that can be used on site by commercial companies. Also did some work which we don't use quite as much, but was kind of an interesting development project that uses up a lot of money without necessarily giving you too much return, but that's life in an R&D sort of world. But this was more to look at the water binding capacity, because that's something that needs to be carefully monitored. If you're trying to accelerate the tenderization, you're also getting close to the area where the water binding capacity reduces and your purge losses might increase. So being able to find ways to keep that monitored so that everything is looked after by the company, so they develop their own database, was all part of this package, if you will, that this exercise is meant to develop. So once you've gone through all that sort of process for the company, then you're actually stuck with the next problem, which is how in the world do they get some return of the kind of investment that's needed to make something like this happen? And this is sort of the main thrust of my talk today, just to identify some of the things that have happened over the years as we've tried to do this, because it can actually be very difficult to get that kind of return just on the basis of claims that you've got better quality. Even if you are measuring it in-house, that isn't really quite the same as what the market's going to think about it. In particular, of course, the problem is that a lot of the things we're talking about here, which is to do with tenderness in particular, is just not visible. You don't know by looking at a piece of meat what its state is in terms of its textural properties and therefore its eating quality. So it's an invisible problem. You've got a situation where you're actually trying to do a sort of a technology push. You're providing the technology further down the supply chain, but you're now trying to push it uphill into the markets without there being a good mechanism to be able to recognize the benefits that this technology is providing. So in a sense, what we're saying is there's the absence of a pull from the market, a demand for this from the market, for the simple reason that there isn't any measurement for that process. If you don't have the measurements, how do you value it? How do you even know it exists? And this is a problem not just in terms of what happens for processors, but actually even on the production side. So if you're looking at genetic improvements to give you a better quality, well, yeah, but how do you know? How does the market know at the other end of the exercise whether that has actually done any good unless they are able to measure it in some way? And at the moment, quite simply, if you're looking at this particular aspect of eating quality, you've got a problem. Where you do, okay, we'll just, I think, one more major slide. So where you do have an endpoint measurement that's visible, the system works. You can get feedback from the market back to the processor, back to the producer. And I think dark cutting meat is perhaps a very good example of that. It's visible in the market. There's a simple measurement system, which is based on pH measurements. It's not the greatest in the world, but it's good enough for this particular purpose, and it doesn't cost a fortune. The processor can do the same thing. They can identify the problem animals, they can separate them out, and then they can feed back to whoever it is producing them to try to deal with this in one way or another. And it's kind of intriguing that there was one company in New Zealand that wanted to provide bull beef to a specific market, but it had to be normal pH. So they actually gave, and bull beef, of course, has got a long history of producing a rather high incidence of high pH meat, gave a premium for bull meat that wasn't high pH, and the incidence of high pH meat absolutely disappeared or dropped catastrophically in a very short time. Because as soon as there was a return for the effort that the producers and the transporters, if there's a return for the effort that they make to get rid of it, it goes away. But the whole thing actually has to begin at the market saying we don't want the high pH, and it goes through all the way down to the producer. So that's the pull that we can't do at the moment with some of the other quality attributes that I've been talking about. So how have some of these things come to pass in the past? And perhaps, again, New Zealand might be a very good example of this, because they did introduce this high voltage stimulation for lamb at a time when lamb tenderness from New Zealand was absolutely catastrophic. It was basically lambs that were processed, no stimulation, straight into freezers. They were actually there was still ATP in the muscle by the time they thawed out in the UK market, and would start contracting when they thawed. So that's how fast they were freezing. Introducing stimulation made an enormous improvement on some of those quality attributes, and in the end, it actually was combined with high stimulation and good temperature. Slower, reduced chilling rates. That combination came known as the accelerated conditioning and aging process. Actually produce some really very good quality product, even though you were still freezing the carcasses within 24 to 48 hours. So to make all this work, the Meat Board, which is basically an industry-supported organization that no longer exists, but was quite influential back in the 80s when most of this developed, they've made a specification that all processors who export lamb had to meet. So this became an industry good sort of umbrella that made it possible to introduce something which for individual companies dealing directly with customers in the market would never have really been able to introduce in their own right. So that kind of industry good initiative, which might be a little bit similar, I think, in many ways to the Meat Standards Australia program, the eating quality program that they developed, but again, which required an enormous amount of support and financial input from an industry good body, which is Meat and Livestock Australia, in order to get through that whole birthing pain problem that is associated with individual companies trying to work with individual consumers. Where we do get probably our best commercial uptake of our principles here is where you've got a company that has a very strong association with one particular customer. So they're in a position where they want to be the principal supplier, or they may be in competition with a limited number of other suppliers to get to that same market, that same customer. And that then creates the incentive to get the best product to that customer in order to keep that business. So that's probably the sort of the niche area that a lot of our business has come from, rather than the more generic sort of wholesaler type meat business that still dominates the industry. As a last point, perhaps, where there's actually a downside is, and we see this particularly in our business in the UK, but it may well apply elsewhere, is that you have supermarkets that then have to try and deal with quality problems as they see it in their product, and therefore impose what they see as being the appropriate processing conditions for the suppliers. Now, that actually creates more problems perhaps than good for a couple of reasons, mainly, I think. One is that those specifications become more than just what you need to produce the meat. It actually gets tied in with a lot of the sales and marketing sort of spiel that's associated with supermarkets as a whole, perhaps. I don't think that's an injustice. But you don't actually have it based purely on scientific principles when that starts happening. But it also then means that you're taking all the agency out of the companies that are providing the meat. They don't have the opportunity to innovate, or it's more difficult for them to innovate because they then have to get the approval of a second organization, and on it goes. So it tends to freeze everything into place rather than allow for innovation. And then, from our point of view, is not a particularly helpful state of affairs. So as this quick final conclusion, I think the key thing I'd just like to stress in all this is, first of all, a lot of the quality benefits that everybody would agree we should have become very difficult to get into place, to put into effect, because of some of these problems that exist within the structure of the meat industry. And in particular, the absence of a way to measure some of the quality attributes easily and routinely, in order then to have a set of specifications and a vocabulary, if you will, by which you can describe what you need, and you can also supply what is being asked for in an effective way. The third point then, based on some of the industry good initiatives that were necessary to get some of these technologies off the ground, the need perhaps for some kind of industry decision-making process in order to provide support in those very early stages when a new technology hasn't been fully validated, and perhaps there's a number of competing technologies that are coming into being at the same time, and you end up with mixed measurement systems, mixed messages, if you will, that make it difficult to define a specification very accurately. Thank you very much.